I'm happy to now welcome Syria Sirhan, the facilitator and administrator of the OTF Connects program, who will be getting us started now. Syria, are you all set?
I am. Thank you very much, Mally. And hello, everyone, and welcome to OTF Connects. We're absolutely delighted with the rich program that we've got scheduled for you for our winter-spring sessions. And I'd like to thank each and every one of you for giving up your time to join us tonight. And so great to see representation right across the province. Welcome those of you in the north. Last night I was saying that we needed more representation from the north, and tonight we have it. So welcome everyone, and it's great to see new participants in the room. Just curious if you could put a green check mark. How many of you were here in the December session that we had to reschedule? Okay, great. I'm glad. I apologize again for the unfortunate situation that night, but thank you for being patient with us and coming back again tonight. Thank you. It's my pleasure to welcome Brian Aspinall, who will be facilitating tonight's webinar, Developing Computational Thinking Through Coding. Brian is a very passionate educator who brings a wealth of knowledge and lots of classroom experience to share with us tonight. So welcome, Brian. The mic is all yours.
Thank you very much. If I could actually just get a green check mark, sorry, if my audio is of good volume and clarity. Oh, great. Okay, perfect. Well, then without further ado, I think we should get started. My name is Brian Aspinall, and I'm an intermediate teacher, grade 7 and 8 teacher from Chatham, Ontario, about an hour south of London and an hour north of Windsor. And coding and computational thinking is something I'm very passionate about. I've been exploring it, alongside my colleagues and students for almost a decade now. For the first 5 years, I really didn't know why the heck I was doing it. I knew it was important, and I saw value in it, but I really wasn't making those curriculum connections like I do today. Certainly kids are engaged, and parents are definitely engaged as well. So I hope today I can just sort of raise an awareness around, how I see it fitting in my curriculum, and hopefully make some connections to your curriculum at different age groups. So just to kind of give you an overview, I want to explore ways that we can introduce principles of coding into a math program without using technology, just to kind of raise an awareness with students, and to introduce some of the vocabulary, some of the words that we throw around in the computer science world that seem so foreign to everybody else, but really are very synonymous to a lot of the terms we actually use in our math program. I do want to share some of my student work, and like I said, of course, it's going to be intermediate, but I hope that we can make some connections to different grade levels that you might have. And then I hope to share at the end some apps, tools, and resources to actually get your students involved in coding with technology to actually create content. As you are aware, I'm a big fan of Twitter, so if you, at any time, please, let's do a back channel chat. I can stop at any time and go through the chat there. So how about, let's start with a few introductions. I'm just curious, what age group do you teach? Are we all on elementary? Are we secondary? Is there a mix there? So if you could just spend a few minutes, who you are, what you teach, including subject area. I think that's important too. I think coding is such a natural fit to numeracy, but it really does fit in all of our curriculums. It just happens naturally in math, but I would like to explore how we can use principles of computer science in other areas, phys ed, art, history, regardless. So if you could just spend a few minutes on the chat box there. Who are you? What grades do you teach? And where are you from? Oh, kindergarten coverage, fantastic. We can talk about ways to introduce, oh, see, yeah, it's going fast, just like we thought it would. Okay. Grade 5 math, language, science. Oh, grade 9 and 12, perfect. 7 language, K-8 math coach. Student success, well, that one would be great too. K-6 French. I do have a French example, fantastic. Librarian. Carolyn, go ahead. That's okay. That's okay. It happens. So I can see from the chat box we've got a whole variety, a whole slew of expertise in various grade levels. So I will do my best to try and make this valuable to everything that you might teach. So what is this coding craze? The Hour of Code started about 3 years ago now, and they've really done a great job of raising awareness. And I have a feeling that's probably why most people are on here tonight, is they've heard of the Hour of Code in some way, shape, or form. Let's try the poll feature. Green check mark if you've done the Hour of Code. X if you have not or have not heard of the Hour of Code movement. A good split there, 13, okay. So in simplistic terms, coding is simply a procedure that tells the technology, tells the computer how to do something. So in written words, we have science procedures to conduct science experiments. In computer language, it's a set of instructions that the computer follows in order, in sequential order, in order to complete a task. But I want to back it up slightly. I want to talk about computational thinking because this is really what is most important. The reason that we are embracing coding and there's this push for computer science and coding in all classrooms is because of the computational thinking piece. So computational thinking was a term that was actually first used by Seymour Papert in the 70s and in the 80s when he was really exploring coding with Turtle and Logo back then. In around 2006, 2007, Jeanette Wing from Microsoft actually raised a little bit more awareness to it and said, computational thinking is critical thinking plus the power of the technology. So if we can encourage our students to solve problems using their own critical thought, coupled with the tools and technologies they have available to them, that's what we now call computational thinking. And I've actually spent the last year and a half doing a lot of research around computational thinking. And here in Ontario, it's a natural fit to just about every area of the learning skills. If we really focus on the learning skills, computational thinking with technology just seems to be a natural fit. Are there any questions so far? I tend to talk fast. I'm not used to talking to a computer without having, an audience on the other end that I can see. So, are there any questions at this point? Okay. So, like I said, computational thinking, it's more of a mindset. It's a way of looking at problems. It's a way of breaking down problems, decomposition, creating simpler problems, and then using technology to solve problems in ways that we haven't been able to do up to this point without using that technology. And so coding is a piece of computational thinking, but so is Minecraft, and so are spreadsheets, and so are making a green screen, and so is anything that you can do, any way that we can get students to create content using technology is a form of computational thinking. Now, coding might be, in many ways, one of the richest ways to touch on computational thinking, and so that's where the Hour of Code has really created their movement, is they're pushing coding because of the strength it has in computational thinking. So about a year and a half ago, my good friend Sylvia Duckworth created this infographic that, if you're on Twitter, I'm sure you've seen it a million times. And we sort of created this list together because people want to know how to code and why to code and where it fits, and is it an add-on or is it a supplement, and how do I justify those minutes in my classroom? We're all so busy. So I thought if we could go through this. So number one, in the bottom left corner, coding allows students to create content and not just consume it. Number 2, coding empowers students and gives them tools to express themselves in really cool ways. This one has really stuck out for me. So if you can picture that quiet, maybe disengaged student profile in your classroom, coding has been a medium for those students to really express themselves in creative ways that I hadn't seen prior to using coding. Number 3, coding teaches storytelling with games and animation. That's just a natural fit. Anytime you tell the computer, you give the computer a set of instructions, it's going to do something. It's going to tell a story. It's going to come to life. Number 4, coding is a place for students to take risks and fail safely. This one has been a game changer for me in my classroom. We really focus on the learning skills. We really focus on feedback. And in the last year and a half, we've had a lot of conversations about removing grades and what does that look like. If we could focus solely on assessment, or more so on assessment and a little bit less on evaluation, will we get more risk takers in our classrooms? And one of the really neat pieces of coding and computer science is the immediate feedback. The students don't have to ask me if their program works, because the computer will tell them it's either going to work or it's not going to work. Secondly, because we really don't currently have this, sort of coding curriculum, it really does become a place for students to try something new and take a risk and fail and then go at it again and go at it again and try again. And I really want to encourage teachers to do it, alongside. I think it's incredibly important to model that process of problem solving and trying something new and sort of being vulnerable, right, and putting yourself out there. Number 5, coding is inclusive and builds self-confidence. I've really found that, like I was saying earlier, the quieter students quite often become the experts in computer science and in coding areas. And they may not be athletes. Sometimes they're not academically strong. Sometimes they are. I don't know. But there are those students who become experts and the go-to people to solve coding problems that other students might have. Number 6, coding supports many principles of mathematics. If you did the hour of code, then I'm sure you noticed you did geometry. Just naturally, coding is geometry. Without even coding for a purpose, you're doing geometry, many of the principles of geometry. Number 7, coding teaches problem solving and critical analytical thinking skills. Back to the computational thinking piece, this is probably one of the most important points on here as well, is the ability to solve a problem through computer code and to think in large spaces. Coding really supports the spatial awareness, spatial reasoning. Quite often students with autism tend to excel in this area just because of the way that their minds work. Number 8, coding is a new type of literacy and will be a large part of future jobs. Yeah, definitely. If you follow the Internet of Things, our stoves and our refrigerators will have Wi-Fi soon. Somebody has to develop that software, and somebody certainly has to troubleshoot that software as well. Number 9, coding develops teamwork and collaborative skills. Also a game changer. When you're focusing on learning skills, students really all want their apps to work, and they want their games to work. And when they're not working, they want to go and seek out those experts. I do focus a lot on the block coding environments, just because I don't teach coding, I don't teach computer science. I don't want students to get frustrated by actually having to write code, missing colons, missing brackets, things like that. So I tend to stick to the block coding environment, which is just like Lego, and the students get to link instructions together to make things happen on the screen. So a lot less daunting, a lot less intimidating, certainly a lot less frustrating. Number 10, of course, coding can help humanity, and coding gives you superpowers, our little fun piece there at the end. I'm going to pass it over now to Mally, who I think is going to put the link into the chat box. This video, if you have not done the hour of code, this video will certainly be new to you. I use this video every year to engage students and to engage parents. I post it on our LMS for parents to go and watch, because there's a lot of value into the message that's being said in this video. So we'll give you about 7 or 8 minutes, And when you're done, if you want to come back and give us the green check mark, we will know that you have completed that video.
We're putting the video in the chat box, so it will take you right to YouTube if you click on that link. And as Brian said, when you're done, if you can just give us a green check mark to let us know that you're finished. Brian, are you talking right now? Okay.
I'm not, but I'm here.
Okay, great. Looks like most people have finished.
Mm-hmm. Maybe 30 more seconds. So coders are the new rock stars, according to the end of that video. Were there any big takeaways there? One of the biggest takeaways, I think, for me personally is anybody can do it. It doesn't matter if you're 5 and it doesn't matter if you're 75. That's such a wonderful video to show your class. It's a great entry point if you want to even begin coding in any way, shape, or form with your classroom, or even to just educate our parents a little bit. Exactly, Christine, you don't need to be scared. I'm constantly asked, yeah, that's right, and you can enter it at any age. Anybody can do it. I'm constantly asked, where do I start? How do I begin? I want to try coding. And it's such an open-ended question. It's very difficult for me to answer that. I don't know a lot about your skill level. I don't know a lot about your comfort level with technology in general. So I've created a model to try and help myself and to help other people get started. And so if you can think of this as a tower, it starts at the bottom of the tower. And I've tried to categorize all of the apps and tools and concepts out there into 4 categories. And of course, there's going to be some overlap in the categories. But in the simplest form, what I call bot coding down at the very bottom. Bot coding is when we would use tools and apps like the Hour of Code. You would get on the app would tell you what to do to move a character or to move a robot, and then you would do it, and the app would tell you whether you were right or whether you were wrong. And if you were correct, you would move on to a more difficult level where you would have to navigate the character or the robot around some sort of terrain on the screen, on the app, or in the game. So it's very much a game-based learning environment. But I call it bot coding because you're moving robots, and there's not a lot of freedom to explore. It tells you what to do, you do it, and then you get awarded a badge or a medal or something, and you move on to another level. A wonderful entry point just to get comfortable with navigating things around a screen. But like I said, there's no freedom to do anything on your own. You can't tell the robot where to go. BBot is a wonderful example on the Apple platform, and I see that that's been posted into the chat box. After you're comfortable with the bot coding environment, what I call open space coding is using the languages that you saw on those bot apps, but to freely move the robot around a blank canvas. So in the bot coding environment, I'm going to pick on the Scratch platform. So Scratch Junior is an app that would fall under the open space coding, but it uses block code. So if you had done something like the hour of code initially, that would be what I call bot coding. So it tells you to move Minecraft Joe across the screen and you follow the instructions. And then you're ready to move on and you want to do something a little bit more. So in open space coding on an app like Scratch Junior, you're free to move the characters however you want to do it using the language that they have created. You can't write code. You have to use the instructions, the blocks that they have provided, but you're free to make the characters move, dance, bounce, whatever you see fit. The open space coding environment is mainly where I stay with my intermediate students. I don't really go anywhere beyond that. Syntax coding would be like a grade 10 high school computer science class. So very much like open space coding, in that syntax coding environment, students are able to create content and games and animations, but they're actually physically writing the code. So that would be your JavaScript, your Java, your Python, Perl, other big computer science languages. That would be syntax coding. So very much like what I call the open space coding, but you've got the freedom to write code and do what you wish with it. Now, I took a lot of slack from my last category because I called it collaborative coding the way I saw it, and a lot of my computer science counterparts said it's always collaborative. You can't put a category at the end. You're implying the other three are not. It's all collaborative. I definitely agree. What the point I was trying to make under the collaborative coding piece, that would be where a developer is using somebody else's existing code to make their app better. And I think the most simplistic example I can give is if you head to a website that says sign up or sign in with Google or sign in with Facebook or sign in with Twitter, that website is using code from Facebook and from Twitter. Instead of creating a new login app or widget, they're recycling Facebook's and Twitter's because so many people are already members of those services. So although every category, of course, is collaborative, when I say collaborative coding at the very top, it's that whole global piece of improving other people's work or using other people's work to make your work better and more efficient. That seemed awfully fast to me. So are there any questions at this point? I hope I haven't lost anybody at this point. I know I'm speaking fast. My wife keeps telling me to slow down, so I'm going to do my best for that. Just going through the chat box. Welcome, Sarah. That's okay that you're late. Thank you for posting the Scratch Junior, the Hopscotch, and the Scratch links there. That's fantastic. Okay, good. Thank you. My speed's okay. So let's move ahead. What is your experience? I think when we asked the poll at the beginning about the hour of code, we had quite a few who had tried the hour of code. But based on the model that I've created, where would you put yourself? So never or bot coding would be the hour of code. If you've done other cool things and you've had kids create content or you've created content using block code, put yourself in open space coding. If you've written code before, put yourself in syntax coding. And of course, if you've developed something super cool using existing code, put yourself in collaborative coding. So we have a few there at syntax coding. I'm just curious as to what languages you were coding in. So whoever you were, if you could just type that into the chat box, that would be great. Bot coding in some Scratch, awesome. Oh, HTML, of course, for sure. People think I'm crazy. I've said it before. I envision a place where even simplistic HTML becomes some sort of requirement for teachers who are, updating portfolios and websites. And I don't know what that looks like in the future, but it wouldn't surprise me if that did happen, even if it were at the faculty level. I do know that Western, I do know that Toronto now offer coding classes at the faculty. If you are a PJ student at Western right now, you have to take a computational thinking course. So things are happening and things are definitely changing. Oh geez, Thomas, Java, Visual Basic 6, HTML, Basic Touring, and even iOS routers. Fantastic. Okay, let's talk quickly about vocabulary, because the word algorithm and the word debug are two words that you do all the time in your classroom at school right now. We just call it something else. So an algorithm, and I put these up as classroom posters because they're great ways to make anchor charts to put up in your room. So an algorithm is just simply a procedure. So you have a procedure in the classroom, how do you make toast? How do you make pizza? How do you play Monopoly? When you take that instruction and you put it onto a computer, we call it an algorithm. Computer scientists call it an algorithm. So it's a list of steps that you can follow to finish a task. It might be a little bit different from a procedure in the sense that it's almost like a choose-your-own-adventure kind of a thing with the flow charts. There's different paths, I guess, if you will, in algorithms. Not that there aren't in, obviously, procedural writing, but that's algorithm. So debug, to debug computer code is to proofread writing. It's to proofread stories. So in my classroom, if we're doing any kind of narrative writing or any writing in general, and we're having our peers proofread, I try and make that connection. When we're doing some really cool things with coding and there's problems in the code, it's not working properly. The process of debugging just means to go back and find those mistakes. Ask somebody, I need a second set of eyes. Can you come and look at my code and figure out where I may have gone wrong? So a couple of great posters there. I can get you those. A friend of mine, Kristen Wydeen, her husband actually created those, and he's got them in a high resolution. If you are interested in having them digitally for a website or a printout, I can certainly get you those. I was just looking at the chat box. Anyone teaching French immersion have the French terminology for this? That's a great question. Is there anybody who can help? Maybe we can create a Google Doc after this, and we can sort of brainstorm some of these ideas and continue the vocabulary conversation too. Crickets, yeah. You should hear it on my end. I'm talking to myself, and I have my dog in my room. Okay. So what is coding? Like I said, an ordered set of instructions to solve a problem or complete a task. So we have to teach, in my school board, we have writing units, and procedural writing is one of the forms of writing that we are told we have to explicitly teach. And so what I've done in the last couple of years is I've taken my students' procedures, and I pick on the easy ones. So let's pick on how do you make toast. A lot of our primary students will make toast, and then they'll write about the steps they did to actually, make the toast. And so I would throw something at my students like, well, what if you didn't have any bread? And somebody would suggest we would go to the store. And then I would say, oh, what if you don't have any money? Or what if there was no gas in the car? Or what if there was a snowstorm? There's an infinite number of what ifs. But the idea is, I used to make every student in my class write the same procedure. And what I do now is I break the entire class into modules. So as I'm saying, how do we make toast? The first student to say, or sorry, if I say, what if we don't have any bread? The first student to say, well, you go to the store. I tell him and his closest buddy to go and write the procedure to get to the store. And then the rest of the class will talk about, well, what if I can't find the toaster? Okay, well, your group is going to go write the procedure to get the toaster out of the cupboard. And then I would go to the next set of students and say, okay, your group has to write a procedure to get to the fridge to find the margarine, let's say. And then at the end of the period, all of my students have written a procedure, But when we put it all together, we have this massive flowchart, and we've actually written an algorithm. It's a really nice way to do this because, as your teacher, you know your students so incredibly well that the scaffolding and the differentiation lends itself nicely, right? So you tell the one group who has to write the procedure for getting the toaster down from the cupboard. That might be a little bit easier, fewer steps than, say, going to the store, things like that. But at the end of the day, everybody in my class is doing the procedural writing. And to bring it together and to map it out, on a bulletin board or a chalkboard, it's a great visual and it's a great thing to look at. And I think there's a lot of accountability, and everybody takes pride in owning a piece of this large procedure. I see there's a high demand for French coding in the chat box. Maybe we have to do another one just on French coding. I will say, just on a side note here, code.org is the, sorry, not vCode, I apologize. Code.org is the Hour of Code site. And if you go to the bottom right corner of the web page on code.org, you can change the language of the website to French and actually have your students do the Hour of Code in French. So they have to know French directions. They have to know up, down, right, left, and a few others in order to actually complete the Hour of Code in French. So that is an option there. Scratch, which I will talk about, Scratch is also offers their website in French as well. So they have to know the French vocabulary in order to complete those tutorials. Okay, so let's jump into coding without technology. I want to expose all students to coding in some way, shape, or form. So we have to consider the equity of access. And so I think the best way to start coding is to just having conversations around the vocabulary and implementing it as sort of a kinesthetic activity. So the picture on the right with the math linking cubes was the kindergarten teacher at my school. She was using the app called Lightbot, and in the Lightbot app, you move a robot around a screen, around a terrain, and the terrain gets more difficult as you progress. What she had her students do was build the terrain. So she plugged she only had one iPad. She plugged the iPad into the projector, and she projected the first level of the Lightbot app. Now this is what I call one of those bot coding apps, where the app tells you what to do. No, sorry, I apologize. This is the open space coding kind of an app. In Lightbot, you have sort of a free rein to move the robot around, but you have to solve a puzzle. So she put the terrain, she projected the iPad up onto her smartboard and had her students build the terrain, because the terrain is blocky like Minecraft, so she used the math linking cubes. And then she had her students create a pseudocode. She was focusing on math words as a kindergarten teacher, so her job was to try and pull the math terminology out for directions. And then they created sort of a pseudocode using symbols as a class, and they used whiteboards to try and write code to move one linking cube from, let's say, the left to the right side of that terrain, just like it was on the game, because I said earlier she only had one iPad and not a class set. Now the students used the iPad as the feedback tool. So as they created their code on the whiteboard, they would go up to the iPad and they would try their code and see if the robot moved to the appropriate spot it was supposed to head to at the end. So again, the immediate feedback piece, the collaborative piece, and introducing principles of computer science in her math program. So she didn't use coding as an add-on, she used coding as a supplement to teach the directional movement for geometry using the math manipulatives, because the kids actually build the terrain. The picture on the left is actually Kristen Wydean's classroom. Kristen is a special projects teacher from Greater Essex County in Windsor, and she turned her classroom carpet into a grid space, like a Cartesian plane. And they had to move stuffed animals. They had to traverse the grid on the carpet, again, using a pseudocode that they created. You can see the students are all holding clipboards there on the bottom right part of that picture, because they had each written pseudocode, just like the Lightbot app there on the right side. Are there any questions at this point? I think these are wonderful entry points, and geometry is the most natural place to get started. I'm just reading what Sarah wrote. Love the application, definitely. Use Lightbot in kindergarten, and the kinesthetic embodied experience is crucial. Absolutely, I completely agree. And being able to manipulate what the terrain might look like, and extend the task, have the students build a terrain that's not on the game. And the student who built the terrain has to make the code themselves using the math terminology instead of always following what the technology wants you to do. Have the kids actually build their own terrain. So what I've done, that's a little bit juvenile, I think, for some of my intermediate students. I went a little too far there. Okay. So what I've done is I create pseudocode for the different age groups based on basically what their curriculums would look like. So if you taught a primary classroom, it might look like move, and then number might be number of steps. It could be centimeters, it could be meters, it could be whatever unit you happen to be studying in that primary classroom. Kindergarten, it could be move left, move right, and it could be hop. Maybe you only want those 3 pieces of code. Again, we're doing this without technology. Picture it in a classroom setting. The teacher, you're creating sort of an anchor chart of what these terms are going to be. And the idea with coding FriendBot, I have students pair up, and one student is the programmer and one student is the robot, and I use the physical space of the classroom or the school as that terrain. So you create this language, this math language as a class, and you put students in pairs and you have them take turns coding each other to move from point A to point B. It might be around the classroom, it might be down the hall, it might be to the principal's office, but you can determine what the block code actually looks like. So in 4 to 6, it might be something like move number of units, it might be turn positive or negative, and then a number, and it might be hop height. And then as you move into intermediate, you start using some of the geometry terms like translate, number of units, rotate with the direction, of course, and again, hop. So create these languages with your students and send them on a mission. And this might take 40 minutes, could take an hour, but they absolutely love it. And it's really neat if you blindfold the robot, the person playing the robot, and see how well the coder can actually do. If you want to extend that, it might look something like this. And so you could have a preset obstacle course in your classroom or school, or you just use the playground outside. But you could actually have the kids then link the code together, maybe on a whiteboard, maybe on paper, maybe using sticky notes to create the symbols. I'm not sure how you want to do that, but those are some great ways. And then have them actually link the code. Put it together, put it out like an algorithm, put it out like a procedure, and then click run. And does FriendBot actually follow suit? What's super cool, super powerful about an activity like this is the natural differentiated instruction again. The kids that are really excelling, you can teach the concepts of looping. So instead of 3 moves, you can say, loop 3 times and then move once. It's a little bit more challenging. Certainly a lot more of that computational thinking piece, the critical thinking piece. Still very much math, of course, but it lends itself to, your enrichment students in the classroom and giving them that next step and that, a little bit more. Again, going down on the right side there where we've got loop 3 and move 1 and at the very end loop 2 and move 1. You can do it however you want. The idea here is to teach geometry using the principles of coding, which is, again, the looping and different variables and things like that. I'm just reading the chat box again. Very easy link to transferring, yep, geometry, absolutely. Definitely. The language exists for kids from kindergarten. It's already there. Yeah. I hope my goal here is to show that we all already do so much of this. My goal is to kind of rebrand this coding push and this, hour of code movement that's happening. We're all doing so much of this already. If we just sort of raise an awareness around it and build the vocabulary, it's such a natural fit to a lot of our math programs already. In this example, you could use grid paper, and you could create, so if you couldn't have students move around for whatever reason, you can do it at their desks or in groups on a carpet or beanbag chairs or in a common space, and you could set the course, on the grid paper, and then the students would actually have to link the block code together, again, using sticky notes or hand-drawn or symbols or dominoes or any other tangible that you have in the classroom. You can use those as the symbols to move the robot around. And in this way, you get to implement a little bit of the measurement piece too if you're using, say, centimeter grid paper there. I could see these probably being a week or two or even 3 in terms of lessons, progressively getting a little bit more difficult. And ultimately, this is probably where you want to head to, is have kids actually code a game on paper or code a game on grid paper, on a tablet or whatever, but not actually using an app or a piece of technology. So in this case, can you unlock the chest? And so what code snippets would you have to link together to move the robot to the chest? Now the chest in this case happens to be locked, and you cannot step over the black squares. So what does that look like? And you can have your students challenge each other and create their own games. And again, this is where that natural, personalized learning environment comes to play, because the kids are going to build the games at their level. They're not going to build something that's far too advanced for them, because they have to know the solution to the game. It's very collaborative there. Okay, that's a lot of chit-chat from me. So, what curriculum connections can we make? And let's remove geometry from the plate. Let's remove geometry from the plate. Are there other ways we can incorporate even beyond math? Let's look at spiraling math strands. So beyond isolated geometry, just geometry, let's look at spiraling math. Can we do multiple strands of math in these activities? And can we link it to, say, literacy? Or can you link it to the arts or history or things like that? So I think Mally was going to jump in there. We were hoping to use the text
tool. If you'd like to use the text tool, it's again, you can write on the whiteboard, put your thoughts on the whiteboard. Another great way to share. And the text tool is the 4th selection down from the top on those tools. And you can simply click on the text tool and then go back over to the whiteboard and click on it, and then a text box will show up, and you can type your ideas. And we'll give you, we said 5 minutes to do that, Brian? You still okay with that?
That sounds great. Yeah, 3 to 5 minutes?
Let's do 4 minutes.
Perfect.
Okay. And if you're on a mobile device, you won't be able to write on the whiteboard, but you can certainly put your ideas in the chat box.
I love the dance idea, dance and algebra and patterning. Create dance patterns and or dancing our code. Certainly integrated into the arts, repeating patterns. Somebody else has mentioned the mathematical process. Somehow they got to look at my slides ahead of time, because that's actually where we were heading with this. Communication and literacy, sending an animated card, social studies, links to mapping, integers on grids for sure. Solving easier problems, absolutely. So decomposition, which is a form of computational thinking, breaking down large tasks into smaller subtasks, and then seeking out peers who might actually assist in those. Natalie says recount writing, absolutely. Have students go back and write about what they did to move the robot or move their FriendBot from one to the other. In many ways, I think that the computer coding in geometry is replacing a lot of my procedural writing, so it's very much literacy as well. I like Christine's connection to Jim. Oh, what's that? We have to find that. Okay, I'm lost. I'm missing it here. Christine's connection. Oh, it must have been written in the chat box. Phys ed strategies for moving up and down the court, for example. Absolutely. In the gym, in the hallway, basketball court outside. I had a student once who actually coded scenarios for basketball plays. So the point guard has the ball, kind of like a game of chess. The point guard has the ball. 4 different things can happen. Let's program those scenarios. What is the point guard going to do, and how is everybody else going to react? Basketball plays, yes, definitely. I had a student once who coded a timer, so it counted down from 60 seconds, and he connected it to some tinfoil on the floor, which was wired to what's called a makey-makey, which is it's a keyboard interface that allows you to trigger things in the Scratch environment. So anyway, this student coded a timer, and you had to touch the tinfoil, which started the clock, run to the other end of the room, and touch another piece of tinfoil, which stopped the clock. And it actually became our DPA activity. So we were trying to see who could get the highest score using an app that this student had actually built in his math class. Okay, I just grabbed grade 3. I just happened to be going through, and I thought this was a great place to look. So really, these activities really touch on these 3 expectations in grade 3. So describe movement from one location to another using a grid map. Identify flips, slides, and turns through investigation using concrete materials and physical motion. Now see, this curriculum expectation says concrete materials, so I think it's incredibly important to do this without the technology. There's a lot of debate around tools like Minecraft. Is it an abstract manipulative? Is it a concrete manipulative? What does that actually look like anymore? You can't physically move it around, you know, in the physical space, but in so many ways you can do it using the technology. The last expectation, complete and describe designs and pictures of images that have vertical, horizontal, or diagonal line of symmetry. So that's just grade 3, location and movement. There's a lot of overlap between the other grades, obviously, and it's such a natural fit. Regardless of what grade you teach in elementary school, this activity, however you personalize it for your grade, really does touch upon geometry. So in the simplistic form, if you do this activity next week, you can say, I'm doing a geometry activity. It's really rich. We're focusing on computational thinking. It's more than the hour of code because the kids are creating it instead of them following a script. But in grade 1, so describe location using language. In grade 2, describe relative locations and paths. Grade 3, describe movement on a grid map. Grade 4, describe location using a grid system. Grade 5, locating objects using the cardinal directions, performing and describing translations. Grade 6, performing and describing rotations, plotting points in the first quadrant. I love the idea of breaking the physical classroom into quadrants. So if you're moving in grade 7 and 8, if I'm having my students move FriendBot from point A to point B, we mark out the classroom and break it into the 4 quadrants and describe what those what the coordinates would be in each point in the room. Number 6, I think, performing and describing rotations. Sorry, we did that one, plotting points in the first quadrant. Number 7, performing and describing dilations, tiling a plane, plotting points in all 4 quadrants. And of course, number 8, plotting an image of a point on the coordinate plane after applying a transformation. I apologize to our secondary folks in the audience. I had just picked on the math document for this example at the elementary level. But I'm sure that you can see your curriculum connections there as well. Christine, grade 2s are expected to draw maps and navigate, describe how they move. Absolutely, so it's a great way to do that. At the beginning of all of our curriculum grades in the curriculum document, we have the math process, which was mentioned earlier. And we all know our math document has been around for a while now, and it says computational strategies at the beginning of every single grade. So I think in so many ways we are already touching upon a lot of this, but I would also argue that coding is already in our curriculums. We just have to figure out where it fits. We don't need another curriculum. We don't need an add-on, I don't think. I think that we just need to figure out where it fits into what we currently have. So if we look at the mathematical process, problem solving, number one, develop and apply problem solving strategies. So I like to use coding to make those connections. So if I have students really struggling on a rich math task, I'll remind them, hey, remember when we did that coding activity? It's kind of like that. You know, we're talking about perseverance and not giving up and trial and error and things like that. Reasoning and proving, developing and applying reasoning skills, computational strategies, using electronic tools to solve problems, making connections among math concepts and procedures, and of course the communication piece, which lends itself so naturally to the oral curriculum we have in our elementary language documents. The big question I always get, and the big question I like to put out there for other people, so how would we assess this? Would we just assess and evaluate the math? Would you assess and evaluate learning skills using an anecdotal? So maybe we can spend another 3 minutes with the text box again, and just throw out some ideas about how we could assess a coding activity like this.
Hi, Maddie. Brian's not talking right now. We're doing the activity that's on the whiteboard.
Sorry, I muted myself to take a drink of water. I'm still here. So learning skills, badges, success criteria, mathematical process, following through on a task, of course, assessing the level of efficiency. That was a big part of my university. So we all could write code to solve a problem when I was in school, and we were graded on who could do it in the least lines of code, who could do it the most efficiently. Now, of course, it's not something we're generally, I guess, encouraging in some of our classrooms now with, you know, at least at the elementary level, I think, with the varying degree of skill level and things like that. But that's certainly how I was assessed when I was in university, and it was, man, was it challenging to try and figure out who could solve the problem in the fewest lines of code. Learning skills, perseverance, we need more do and not always write. For sure, for sure. Performance tasks. Students can create challenges for each other, solving each other's problems. And even beyond the classroom, right? You could have students create things for other classrooms, or maybe that could be homework. You know, hey mom, look what I did at school today. I've created a game using this piece of graph paper, and I need you to move the robot from point A to point B. And so it really engages. It's a great way to engage our parents with homework too. And I guess it's a little bit of a change from the quantities of homework we traditionally send home. Okay. In this example, I create code because I want students to deconstruct shapes. In my language program, we talk about deconstructing media all the time. In grade 7, my students have to know, and they have to sort and classify quadrilaterals and triangles. So they have to understand that an isosceles triangle has 2 angles the same and 2 side lengths the same. So what I do is I use block code to write a procedure for drawing a shape. So in this example, I would post this on my smartboard, and I would say, what shape would this draw? You are now the computer. Follow the algorithm. And what does it look like? But not just what shape, how do you know? Because I want them to look at this. And if you look at this code, it says move 300 steps. Just look at the blue. We'll ignore everything else. And I love that it's color-coded as well. Move 300 steps. Point in direction 0. Sorry, can you not hear me? Give me a check mark if you can hear me. I see we have some audio issues. Green check mark if you can hear me. Okay. Do you have the volume turned up? Okay. And Mally, I'll leave that with you, I think, to see if you can troubleshoot for Natalie. So yeah, it's definitely a rectangle. It says move 300, point in direction 0, ignore the weight, move 150, turn 90, move 300, turn 90, move 150. And this is a great entry point for me to talk about the sum of the angles of a quadrilateral being 360 degrees. That is a specific curriculum expectation that I have to teach. But I can do this almost in a backwards manner. So now I'm encouraging the students to figure out what shape it is based on the properties of the shape. And what's really cool is to actually have them go out and try it after. So make this code. What does it draw? And here's another one. If I changed 90 to, say, 80 in the first blue box that has those degrees, what happens on the screen? Now it's no longer a quadrilateral because it's not a closed shape. How could you then go ahead and close it? And students would then, maybe change the other one at the bottom from 90 to 100. And we've created a parallelogram just by tweaking 2 variables. 2 very simple variables can be changed, and all of a sudden the program is going to draw a different shape, a parallelogram, a rhombus, or something like that. I love using this activity for triangles explicitly because students get an idea of the relationship between height and width. If I could post code like this and say, what kind of a triangle? And they might say it's an equilateral because I see that there are 3 angles the same. But if I gave them something like a scalene, they could describe that it was an obtuse scalene. They could tell me it's really wide and it's really short. Or they could describe that it's a tall triangle and it's really narrow just by looking explicitly at the numbers that exist in the code there. In my literacy program, like I said before, I have students write procedures. So I'm going to pick on the factors of a number. I'm going to pick on number sense a little bit. When I first started teaching, I would assign multiple questions for homework and multiple textbook questions to students. What are the factors of 10? What are the factors of 20? What are the factors of 30? And I would expect them to complete all these questions. And I thought there's got to be a way to engage this a little bit differently. So I changed the question from what to how. I changed the question from what to how. How do you find the factors of a number? And I would have them actually write it out in English terms. So what do you do? Like, what does it actually look like? Because if you can tell me how to find the factors of 10, then you can tell me how to find the factors of 30 and any other composite number. And after I've done this in English language, I have them go find the equivalent block code. And so now I have students actually building an app that will find all the factors of a composite number using the equivalent block-based code from the written language that I might have. So very much cross-curricular, and it's a very engaging lesson. It might take an entire day. That might be all you do, in one day, but it's reading and writing and oral and media, and then all of the learning skills and all the computational thinking that goes into it that we've been talking about here as well. In other grades, you could talk about write a procedure, write an algorithm to tie your shoes, wash your hands, do jumping jacks. Just other examples of entry points to at least start having conversations about coding. We all do these things in our writing program. If we teach at the elementary level and we teach language arts, we are all doing this in some way, shape, or form. It might be a health class, you know, brushing your teeth. It might be a health lesson. But you tweak it ever so slightly from procedure to algorithm, have students draw flowcharts and create multiple scenarios, and all of a sudden we're coding our brushing our teeth. We're coding that, you know, and having our students go home and have those conversations with their mom and dad, or maybe have students go home and find a task they do at home with their family and write an algorithm for that task at home and come back and share it with us the next day back at school. So where does coding fit? The 6 C's really show up a lot today in education. I call them buzzwords, but I think they're incredibly important. So where does it fit? So if you want to quickly use the image tool again, for example, I'm going to drop the smiley face there. If you want to use that image tool, where do you think it fits? And if it fits in more than one place, let's treat the middle 6 C's circle as the Venn diagram. So if you think it fits in all of them, you would drop it in the middle. If you think it fits best in creativity, you would drop it there. So let's spend 30 seconds. Where do you think coding fits? Character education, citizenship. So I guess we can all agree that it pretty well fits in every single category in some way, shape, or form, obviously depending on the task that you're trying to do. And you know, whether you call them the 6 C's or Scratch calls them the 4 P's, it's very much the learning skills that we have here in Ontario, the soft skills that we keep continuing to focus on in education and reading about the importance of those soft skills. So let me move over to another quick example of coding without technology. So in computer science world, computers have to sort data before they can retrieve data. So if you go onto Facebook and you've forgotten your password and you click that, I forgot my password link, and it says enter your email, and it emails you your password. The code on the Facebook page has to go to the database, of course, sort the data, find you, and then send you that information. And so there are sorting algorithms that have been created in the 60s, 70s, and the 80s that computer scientists use to sort data. So they write code to sort data, and they use different sorting algorithms depending on what the needs are of that data. So what I have students do is actually sort data. It's another kinesthetic activity. So I assign students a card with a random number on it. So in this example, we have 413723, and we're going to focus on the bubble sort algorithm. In bubble sort, a computer will compare the first 2 numbers, and it will push the bigger number to the top, like a bubble. And then it will move down and compare the next 2 numbers, and it will push the bigger number to the top. It'll move it to the right, and then it'll move down again and push the bigger number to the top. It'll continue to do that, hence the reason it's called the bubble sort. So I would give students a random set of data or range of data like this, and I would say, okay, we're going to do the bubble sort now, and I would have them stand on a line in the hallway. And so in this example, 413723, obviously the 4 is going to swap places with the 1. So I've actually done this, I've tried to create it as a stop motion. So the next 10 or so slides, the only thing that's going to change are these numbers. So if you notice that not a lot is happening, it's just because I'm advancing the slides, but only these numbers are going to change. So I'm going to hit the right arrow now, and you'll notice that the 1 and the 4 have switched spots. And so the computer now will move on to the next 2 numbers, and it's going to compare the 4 and the 3. And because the 4 is larger, It's going to swap those two spots. And now it's going to move on and compare the 4 and the 7. I've lost a bit of formatting here when we uploaded the slides, so my arrows have moved a little bit too far to the right. We're still comparing the 4 and the 7 right now. And obviously, because the 4 is smaller than the 7, there was no change in that case because the 7 is the larger number. It's already the bubble on the right side. So now we're comparing the 7 and the 2. Again, I apologize. My arrows are too far to the right. So I'm going to hit the right arrow right now, and you're going to notice the 2 and the 7 have swapped places because the 7 was larger than the 2. And again, the 3 and the 7 are going to swap places. And this would repeat. So the whole set of data has not been sorted yet, but the computer would then start over at the beginning and compare the first two. And because the 1 is smaller than the 3, nothing's going to change. The 3 is smaller than the 4, nothing's going to change. Again, I apologize. My arrow should be to the left here. We're comparing the 4 and the 2, and because the 4 is larger, they're going to switch places. Now we're comparing the 4 and the 3, and because the 4 is larger, they're going to swap places. And now we have sorted a set of data. And the reason I do this with my class is because in grades 7 and 8, I aim to teach mean, median, and mode. And in order to find the median, we have to have sorted data. And so I would have students stand on the line in the hallway. We would run through the bubble sort, talk about how it fits in computer science, why it's efficient, and then I would bring it back to math and say, okay, now who's in the middle? What is the median? What does that look like? What's the most occurring number? So it kind of brings mean, median, mode a little bit more engaging, I think, there. So it's going through it again. Okay. So my last part of this presentation, I just wanted to share some student work. So in this next example, this student, let me give you his background. He was in grade 8 last year. He was kind of a disengaged student. He was involved in sports. He's gone to the applied stream at the high school level, but his French teacher said, we've got to do directions in French. And he said, can I create a French game? He knew I was a big Zelda fan from the 80s, so he said, I'm going to recreate Zelda. So on the right side of the page, he's created this castle, and it's a top-down castle. And the instructions, he has written the instructions in French, and it tells Link, the character, which door to go into. And there's actually 3 levels. So if you go into the right door, you're told again in French which door to go into next. There's 3 levels, and then there's the dragon at the end. So the French teacher was teaching directions, but what I started to do is make this his entire geometry project. So these are a couple of screenshots of the code from this French project, and I've thrown the arrows on there just to make some awareness to the Cartesian plane. In order to make his character Link move up and down, he has to change a y value. Positive y makes the character move up, negative y makes the character move down. In order to make his character move left and right, same thing applies to X. And you'll notice in the bottom middle of the screen there on the bottom, that arrow I have, you see the glide where it says glide 1 second 2, and then he's got a coordinate there. He wants his character to start at a certain point on the screen, but he's really just translated that character. So he's doing the majority of my geometry expectations are now happening in his French project. This is, yes, Melissa, this was done in Scratch. For the sake of time here, I'll let you look at it. If you want to, I think Mally is going to post the link. You can check it on the QR code, but like I said, on Apple, it's not going to work, just because Scratch is Flash. But if you do click on that link, you should hear his game, and you should be able to quickly run through his game. Now, keep in mind, and this is a conversation I have with parents a lot, when we're doing these coding things, what you see when you click on this link is the tip of the iceberg. You're seeing his final product, but you're not seeing the 3-week process that went into this. And I'm going to refer to Growing Success, where we talk about focusing on process of learning and not as much on the endpoint, I guess, here, because what you see, you're going to complete his game in about 30 seconds. It took a lot of work. He wanted to quit a dozen times. He was frustrated, but determined to finish it, and it was such a moment to celebrate. He actually finished it the last week of school before grade 8 grad. It was just a huge moment for this student in particular, because like I said earlier, he didn't have a lot of success in his academic career in elementary school. So this was a big, big moment. So I'll give you about 30 seconds to look at that. So Mally, if we could start the timer. Or sorry, how about let's do the poll when you are finished with that. I did laugh out loud at the "I can't win" comment there. The dragon's just too fast. How many of you noticed, though, like I said, it was about 3 days before grad when he finished this. His final title screen was written in English. I said, come on, you've made it so far. Anyway, he wrote the final end credit scene there in English, even though it was his French project. Like I said, that took him 3 weeks, but it was something he did at night. His parents wanted to know what was he doing at night, because he seemed to be on the computer for hours at a time. But he fell in love with this, and it was in my opinion, just a game changer for him. It made math authentic. All of a sudden, he needed to use geometry to actually solve a problem because he wanted his character to move across the screen, and he wanted the dragon to move back and forth by itself. So that's in a repeating pattern, and all he's doing is changing the x value on a number line to make the dragon go back and forth. But I don't know how many of you noticed, there's such subtleties in there. When the dragon hits the wall, his character actually flips. It didn't do that initially, and the student said, well, it looks ridiculous. He's hitting the wall, and then he's walking backwards. I have to actually make him flip. Well, that became another point of conversation about geometry and what flips are. And I mentioned Pac-Man, and the game of Pac-Man is from 1981, is our entire strand of geometry at grade 7 and grade 8. Another example I used in my classroom, this student created a coin flipper to teach probability, which I thought was really, 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 really unique, because now he spiraled math. He wanted the coin to actually animate, so the coin moved up and down, which is all geometry, as you just saw. All of those things you see on the left side, on the left picture, where it says flips, heads, tails, those are variables. So now he's doing principles of algebra because he has to store information in those variables. And I could tie it into science and talk about dependent and independent variables. But the goal here, the task, was to actually create a coin flipper to teach experimental probability. So our expectation in grade 7 and 8 is to teach that the more times you run the simulator, the closer the experimental probability gets to the theoretical probability. So if you flip this loony 1,000,000 times, it should show 50-50. So this student had to use geometry, number sense, principles of algebra to actually create the probability tool to teach the law of large numbers. It was incredibly rich, incredibly powerful, and because he threw all of his code into a loop, there's a turbo button, you could flip his coin really, really, really fast in a short period of time. So I could hit the turbo button and I could type in 1,000 and it would be done in milliseconds because the computer can do it so quickly. But I can now teach experimental probability and theoretical probability very, very fast using a tool that this student made. So before we wrap up here tonight, let's just talk quickly about how to actually get started with coding with technology. So a great entry point to get your feet wet is the Hour of Code. The Hour of Code officially ran for Computer Science Week in December, but you can do it anytime. It's always up. It's there all year long. This year they had Minecraft Steve involved, so you move Steve around the page. It's great for all ages. Like I said, you can change the language of the website to French. You can change the language of the website to any language you want and have students complete the Hour of Code in that language. Great entry point. This would fall under what I called earlier the bot coding piece. Not a lot of freedom to do anything, but at least get your feet wet with creating algorithms, clicking run, debugging code. If you're ready to go to that next step and actually create content and you have access to a computer lab, the tools that you just saw, the Zelda Castle, those were all created with Scratch, Scratch is created by MIT and has actually been around for over a decade now. So over a decade ago, MIT acknowledged the importance of computational thinking, and they created this tool. They branded it under what they call the 4 Ps. So passion, play, projects, and peers are the 4 Ps that they want to see all students engaged in. So that one is scratch.mit.edu. Again, this will be recorded, and I will certainly post these slides later. If you want to email me and say, hey, what was that link, I will happily get back to you. TouchDevelop by Microsoft is fairly new. What I love about it is it's block code, but for your students who excel at that, you can turn block code off, and they actually have to write syntax. It's not an app. It works in the browser. So it works on all of the Apple products. Because of that, they've designed it in such a way that it is to work on every browser, on every device. So it is a really good tool if you are in one of those iPad environments that many of us are in nowadays. It can be quite challenging. I do love my Scratch environment, but TouchDevelop is a great place to go to. And they have some really good tutorials in there that your students can follow. So back to that bot coding area, students can go on to TouchDevelop and they can create Flappy Bird right now. And you as the teacher, go lean over your kid's shoulder and watch what they're doing with Flappy Bird, and you'll see the geometry in the code naturally. They want to make the bird fly up, they have to change a Y variable. If they want to implement gravity into the game and make the bird drop, they have to, again, make the Y a negative. So I'm just trying to catch up on the chat box. Yeah, the interactive QR codes. Good, I'm glad they're working. I was concerned that we would scan QR codes and land on a page that said your device doesn't support Flash, but I thought at least you would have access to those links by doing it this way. Okay, lastly, if you have access to technology and you want to get started with apps, Scratch Junior, after the hour of code and introducing kids to block code, is a phenomenal place to start if you are a primary teacher and you want to do some really cool things with computational thinking. So Scratch Junior has built-in block code snippets. They're color-coded. It's like Lego, only certain pieces fit together, but you make the characters do some really cool things on the screen. You could have students write stories about what's happening. They could create screensavers or greeting cards or things like that. Tinker is all grades in elementary school. What's unique about Tinker is it has built-in lesson plans, and you can actually assign lesson plans under the Tinker platform as a teacher after you've added the students to your class. So you can monitor their progress as well and actually see their work in Tinker. So Tinker is web-based as well as an app. Hopscotch has been a game changer for our junior program at our school. They absolutely love Hopscotch. It's very, very, very similar to Scratch. I can actually see it eventually becoming, you know, the iPad Apple version of Scratch. It's not an app. I'm sorry, it's an Apple app. It hasn't been created by Apple. It's on the Apple platform. But the Hopscotch community is growing so quickly. There's a lot of really cool interactive things that you can look at in their community there, just to give you an idea. Viswick is a Canadian startup out of New Brunswick, and they actually helped get computer science into elementary curriculum in New Brunswick starting this coming September, and they've actually used their app as that driving force. So they've sold their app to the ministry out there. Viswick is very, very challenging. It's not a toy. The CEO of Viswick says it's for when you're finished with Scratch and you want to do something more. So it's block-based code, it's visual coding, it's flowchart coding. You can build apps and games. You can try them out in the Viswick platform. You can actually export them from Viswick to Apple and to Android. The biggest piece that I love about Viswick is it supports the entrepreneurial piece. You can create apps and games in Viswick and then sell them. So Viswick is also a marketplace. So if you do teach at the secondary level, students can create really cool things and sell them in the Viswick marketplace. Now it is new, so the marketplace is not entirely large, but I do think that we will see a lot of Viswick in the next little while. Unfortunately, I don't think we have time for the design challenge, but I'm sure many of us already have an idea, or I hope, I hope we have an idea of where we can make this fit. If you want to get started with some lessons that have already been built around Scratch and our Ontario curriculum I've recorded lessons for intermediate, but at least you can watch them and you can have your students watch them too. Even if you're not a grade 7 or 8 teacher, I have recorded lessons on how to create the coin flipper app I showed you, the probability app, so you can watch them on my YouTube channel, or you can just have your students watch them on that YouTube channel. I would love to have other students create these video lessons too and share them on YouTube. On March 8th, Peter Skillen and Brenda Sherry will be facilitating a webinar on Turtle Art and Scratch. I am a big fan of Peter Skillen and Brenda Sherry, and Peter Skillen is a fantastic speaker who comes with a wealth of knowledge and information about constructivism. He knew Seymour Papert personally. He worked alongside Seymour Papert. Peter Skillen has been pushing computational thinking for his entire career now, so 30+ years. Fantastic, fantastic. I would highly recommend checking them out. There is also the ACSE conference in Toronto, which is on February the 27th. If you're interested in coming to a high school computer, sorry, I shouldn't say high school, a K-12 computer science conference to see some of these things in action and to play with some hardware tangibles like Makey or Raspberry Pis or anything like that, if you've heard those words, that is on February the 27th, acse.net. I'll type that into the chat box. And my clock says I'm a minute late, so I apologize for going over. I will happily take any questions, and I can stay on here for a few minutes if anybody would like to have me go over anything else.
Thank you so much, Brian. It was such an informative session. Thank you for sharing so many useful ideas for engaging students and certainly ways to make coding and connecting coding to the different curriculum areas. You've done a great job with that tonight. Thank you.
Thank you very much for having me.
Thank you, Brian. I would like to thank each and every one of you for giving of your time to participate in tonight's webinar. And I'm sure you'll be able to use Brian's ideas with your students. Brian covered a lot of information with us tonight. And since the session was recorded, you can go back and review the session at your leisure. You'll be sent a link, an email tomorrow with the link to the recorded session that you can share with your colleagues also. Once you sign out of tonight's session, a feedback form will pop up on your screen. Please take a few minutes and fill that out. We read them all over and we take your suggestions seriously. Now, one of the things that we are considering, since we had so many people registered for the session, we had to up the numbers a couple of times. We are considering having Brian facilitate a second session on coding. So if you think that this would be very helpful to you, please do let us know in the feedback form, and then Brian and I will talk about ways to support you in another webinar. I'm happy to, on another note, I'm happy to announce that this year, teachers who participate in OTF Connect will receive a certificate of participation. So there is a hook. Once you complete that feedback survey that at the end, you will be prompted to create a certificate for yourself, and then you can save it as a PDF and print it. So Mally has very kindly posted sessions that are going to be facilitated in the month of January. Tell your colleagues about it. Encourage your colleagues to check out the calendar, and I would encourage you to check out the calendar beyond January because, as I said earlier, we certainly have a very rich program. So Thank you again to each and every one of you. Brian, thank you for a fabulous session. And Mally, thank you for all your work in making everything run very smoothly tonight.